Hello, AP Stats students. Last time we talked about completing a significance test. Today we're going to talk about errors in a significance test. When we draw conclusions from a significance test, we hope our conclusions will be correct. So we have this truth about the population, but rarely do we know what that truth is. And then we have our conclusion based on the sample. If we reject the null hypothesis when the null hypothesis is actually true, that is wrong and you committed an error. If you reject the null hypothesis when the null hypothesis is false in favor of the alternative hypothesis, that's correct. So if we fail to reject the null hypothesis when the null hypothesis is true, that's correct. If you fail to reject the null hypothesis when the null hypothesis is false, that's wrong. And so there are special names for these type of errors. The first one, when you reject the null hypothesis when the null hypothesis is true, is called a type 1 error. And when you fail to reject the null hypothesis when the null hypothesis is false, is a type 2 error. What happens when our conclusions are wrong? There are two types of mistakes we can make. So the type 1 error is rejecting the null hypothesis when it is actually true. This is the 1 in a million case. Where the null hypothesis is innocent and the alternative would be guilty. So determine they are guilty when they really are innocent. The type 2 error is failing to reject the null when it is false. And the way I remember which one is which is the type 2 has the two F's in it. So fail to reject the null hypothesis when the null hypothesis is false. Okay, so the type 2 error has the two F's in it. So determine they are innocent when they really are guilty. So in a type 1 error, if you look at these diagrams, you find this. So this is what you find. And it's a low probability based on chance. But you should have found this. So the type 1 error, that is a low probability. It did happen. It happened by chance. The second diagram, you find this, but you should have found the smaller probability. So you should have found this right there. And you doesn't mean you're wrong, but your sample just didn't give good enough evidence. All right, let's do an example. Heading into the election, Jack needs 50% of the vote or higher to win the election. Jack is feeling pretty confident that he will win the election. Is this confidence warranted? The null hypothesis is P equals 0.5. The alternative hypothesis is P greater than 0.5, where P is the proportion of votes needed um, in the election. So describe in context a type 1 error and its consequences. So the type 1 error is rejecting the null when it's true. So if you're going to reject the null in favor of the alternative, this is what you end up determining. You determined that Jack had more than 50% of the votes when he really didn't. What could be a consequence? And this, you just have to list one. So one consequence could be that Jack decided not to run more ads to try and win more votes because he felt safe. So he wanted to save money. So consequence would be decided not to run more ads to try and win more votes because he felt safe. Tried to save money. All right. Describe in context a type 2 error and its consequences. So a type 2 error is the fail to reject the null hypothesis when it is false. So here you are determining, if you're going to fail to reject it, then you have determined that Jack had 50% or less of the votes when he really didn't. And the consequence would be spent money on ads to gain votes he didn't need. Right. Our next little topic is error probabilities. What's the probability of making these different types of errors? So we can assess the performance of a significance test by looking at the probabilities of making these two errors. So the probability of making a type 1 error is equal to the significance level. Right? And so alpha is your significance level. The probability of making a type 2 error is known as beta, which you don't have to worry about, you don't have to calculate. So that is the probability of making a type 2 error. Right. Okay. As far as the other thing that we're going to talk about in this particular box is what is known as power. So the power is the probability of correctly rejecting the null hypothesis. And the power is directly related to a type 2 error because the power is equal to 1 minus beta. So to have a higher power, meaning correctly rejecting the null hypothesis, that's going to decrease your chance of making a type 2 error. So the higher the power, oh, what can I write it down here? So to increase the power, so correctly rejecting the null hypothesis, you will decrease the chance of making a type 2 error. Why is power important? The probability of making a type 2 error is equal to 1 minus the power. So the higher the power, the lower the chance of making a type 2 error. Oh, had it right there. Low power means the null hypothesis is unlikely to be rejected and the experiment will be inconclusive. Meaning you did all that work for nothing because it doesn't tell us anything. Unfortunately, calculating the power of a test can only be calculated if you know the true population value, which we rarely know. However, you could have something where if this were the true population, then what would be the power? So we are going to look at this situation here. So this first picture is the sampling distribution based on the PO from our null. And there is a typo here. This should be P equals 0.08. So the test is P equals 0.08 for the null at a alternative P greater than 0.08 at a 0.05 significance level. For the sampling distribution, if P equals 0.08 for N equals 500 is shown over there. The green line, well, here, let me explain what the green line is. So this right here separates your probability of your type 1 error. So right here is rejecting the null hypothesis when it's true. So that's what the probability of the type 1 error is. Okay, so this is in 5% of the sample. So our significance level is 0.05. So rejecting the null hypothesis when the null hypothesis is true, this is in 5% of the samples. And so that's what you have right here. If you have 5% there, you're going to have 95% below. And that's what we are calculating to figure out how we get this. We have to do an inverse norm. So the inverse norm, we want to the left of the green line. And so the area is 0.95. The mean is 0.08, and the standard deviation based on that mean is the square root of 0.08 times 0.92 divided by the sample size of 500, and it gives you 0.0121. And that gives you the standard deviation, sorry. So giving us the standard deviation 0.0121, plugging that into the inverse norm, we have this value 0.0999563, which is what I've circled right here, values of p hat, and that gives us that particular probability. Now, what if the true proportion is 0.11 because you ended up getting an actual population proportion, say, based on a census? So what if this were the case? So the sampling distribution of the true proportion is drawn. So you still have that green line. This is correctly, this right here is correctly rejecting the null hypothesis. Okay, because that's our power. There we go. And in order to do that, you are going to calculate the probability of getting that 0.099 or higher for the sampling distribution for p equals 0.11. So the probability of making a type 2 error is that 1 minus power. So we use our normal CDF where our lower bound is 0.0999, our upper bound is 100, our mean is 0.11, but we have this new standard deviation based on that mean. So to find the standard deviation, we would use the square root of 0.11 times 1 minus 0.11 over the sample size, and you get 0.014. And you enter that in your calculator, do the normal CDF, and you get the probability as 0.7517. So this is your power. And what does that mean? It means that there is a 75.17% chance of correctly rejecting the null hypothesis when the true proportion is 0.11. And so in this particular case, the higher the power means the stronger the test. So it really helps you if when you're designing a test. So power is the probability of avoiding a type 2 error. Okay, let's look at an example. A certain cigarette brand advertises that the mean nicotine content of their cigarette is 1.5 milligrams, but you are suspicious and plan to investigate the advertised claim by testing the hypothesis. So the null hypotheses, where the mean is 1.5 versus the alternative where the mean is greater than 1.5 at the 0.05 significance level. So I know we're not doing proportions, but this is just learning more about the content as opposed to you're not actually doing any kind of problem. So you're just kind of understanding type 1, type 2 errors and power. You will do so by measuring the nicotine content of 30 randomly selected cigarettes of this brand. Describe what a type 1 error would be in this particular context. So type 1 error means you're going to reject the null when it is actually true. So if you're going to reject the null when it's true, then you're going to favor the alternative hypothesis. So you are going to determine that the mean content of nicotine is greater than 1.5 milligrams when it really isn't. Okay. Describe what a type 2 error would be in this context. So type 2 error, rejecting the null hypothesis when it is false. So you are determining that the mean content of nicotine is not greater than 1.5 milligrams when it really is. From the perspective of public health, which error in this particular situation, type 1 or type 2, is more serious? Explain. Well, if you have a chance to really look at the A and B, you would see that a type 2 error is more serious in this case because the more nicotine has serious health risks. While type 1 oops, would reduce nicotine more. So that's a good thing. Oops. You have determined that at the alpha of 0.5 significance level, the power of the test against the alternative hypothesis, mean mu equals 1.75, is 0.88. Explain what the power of the test means in the context of the problem. So in this particular case, there is an 88% chance that we will correctly determine that there is more than 1.5 milligrams of nicotine on average in a sample of 30 cigarettes. Okay. How is power affected by different parts of your study? So, in order to achieve higher power, you can increase your significance level. When you increase your significance level, you do increase your type 1 error. But you decrease the type 2 probability. Okay. And then another way to have a higher power is increasing your sample size. Decreasing standard deviation. Increasing the difference between HO value and the true population value. And using a one-sided test. Okay, for lower power then, you would decrease your alpha, decrease the sample size, increase the standard deviation, decrease the difference between the null value and the true population value, and use a two-sided test. Okay, so let's take a look at an example on how that chart will help us. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait more than 2 minutes to receive their food once their order is placed. Based on store records, the proportion of customers who had to wait at least 2 minutes was P equals 0.63. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. During the next month, the manager will collect a random sample of drive-through times and test the following hypotheses. So the null hypothesis, 0.63, and the alternative that the proportion will decrease, so it would be less than 0.63, where P is the true proportion of drive-through customers who have to wait more than 2 minutes after their order is placed to receive their food. Suppose that the manager of the fast food restaurant wants to change some aspects of his study. How will these changes affect the power of the test? So, number one, to reduce the possibility of a type 1 error and avoid the possibility of unnecessarily paying an extra employee, the manager reduces the significance level from 0.10 to 0.01. So reducing the significance level will decrease the type 1 error, and that will decrease the power. So, okay, reducing the significance level, so reducing the significance level, so reducing alpha decreases the type 1 error and it lowers the power. Okay. To justify the additional cost of the extra employee, the manager decides that the true proportion must be reduced to at most 0.53 instead of 0.63. So that's a big difference. So you're increasing the difference between the null value and the true population value. So that increases power. And lastly, to get faster results, the manager reduces the sample size from 250 to 100. So reducing the sample size, so decreasing n, yields in a lower power. Right. So our last little bit is when you're planning studies and determining the sample size, you must have some questions that must be answered to decide how many observations we need. First one, significance level. If you insist on a smaller significance level, such as say 1% rather than 5%, you have to take a larger sample. A smaller significance level requires stronger evidence to reject the null hypothesis. Practical importance. At any significance level and desired power, detecting a small difference requires a larger sample than detecting a larger difference. And power. If you insist on higher power, such as 99% than 90%, you will need a larger sample. Higher power gives a better chance of detecting a difference when it really is there. But here's the problem with the larger samples. It is more costly for larger samples, and it is more time consuming. There's more data to look at, and you must be careful with that 10% rule. So there's that to think about when determining a sample size as well. And those are your notes for 9.1b. Have a great day, AP Stat students.